Okay, it's 8:30. Hello, my name's John Orchard. I'm the federal point of contact for the NEUP program within the Spent Fuel and Waste Disposition Office in the Department of Energy. And I'm going to present the, let me see how we go here. Nope. How do I, damn. Tell me again how I go down to the next slide.
So John, make sure to click on your PowerPoint presentation and then try clicking again.
Ah, okay. Easy once you know how. Okay, the Office of Spent Fuel Disposition. Well, I've got the missions for the DOE Office of Nuclear Energy here, which is to advance nuclear power, as you can read, and the mission for the Spent Fuel and Waste Disposition Office is to identify alternatives and conduct scientific research and technology development to enable storage, transportation, and disposal of spent nuclear fuel and wastes generated by existing and future nuclear fuel cycles. The Department of Energy partners with a number of national laboratories, and here's a list of the labs we participate with. The grand challenge for our spent fuel disposition campaign is to provide a sound technical basis for the safety and security of long-term storage, transportation, and disposal of spent nuclear fuel and waste from the nuclear energy enterprise. And that helps to support the establishment of spent nuclear fuel management and disposition pathways. Our research needs, we have two areas of research. One is the disposal of the spent nuclear fuel and high-level waste, and the other is the storage and transportation of the spent fuel and high-level wastes. Under disposal, our needs are to provide a sound technical basis for the assurance that the U.S. has multiple viable disposal options available when national policy is ready. And we're doing that by reviewing generic disposal sites. We want to identify and research generic sources of uncertainty that challenge the viability of the disposal concepts. We want to increase confidence in the robustness of the generic disposal concepts to reduce the impact of site-specific complexity. We want to develop the science and engineering tools required to address the needs above. In the storage and transportation area, we want to develop the technical bases to demonstrate used fuel integrity for extended storage periods, to develop the bases for fuel retrievability and transportation after extended storage, and for transportation of high burnup fuel. High burnup fuel is becoming more and more used in the industry. Here's a figure showing a typical generic repository, and we're looking at a number of geologies for the deep geologic disposal. And some of the geologies are clay shell, another is salt. We're also looking at crystalline rock, and we have in the past looked at tuff, and there are other similar geologies such as alluvium that we're also looking at. In the disposal, the barriers for waste isolation, which is what we're looking for. We have the natural barriers, which can be saturated or unsaturated rock, and the environment can be a reducing or oxidizing environment. We have also engineered barriers that we put into place, such as a backfill around the waste package, and then the container, an overpack of the waste package itself, and then the waste form, which is typically either glass or ceramic. The glass is typically used in the high-level waste disposal, and the ceramic is the uranium oxide pellets of the spent nuclear fuel. Within the storage and transportation area, we have 4 different areas of focus. One is the fuel itself. 2 is the cask. We have schematics of the fuel bundle or fuel assembly, and a typical vertical cask. There are also horizontal casks. The Disposition, which is a independent spent fuel storage installation, and composed of the storage pad, the rebar within the concrete of the storage pad, and physical protection of the waste. And then we're looking at monitoring systems for remote inspection. We're looking for in-package sensors and security. Again, the focus areas for the university research proposals are the areas of disposal and storage and transportation. Within the NEUP FOA, we've got the two headings of FC 4.1, which is fuel cycle 4.1 is disposal, and fuel cycle 4.2 is the storage and transportation. These grants are required to be industry-led. They value up to $800,000, and the duration is up to 3 years. Specifically, what we're looking for in the FC 4.1 disposal area is to develop new and improved concepts, data, and models to demonstrate total system performance of the permanent disposal of spent nuclear fuel and high-level radioactive waste. This should apply to a variety of generic deep geologic repository concepts in clay shale, salt, crystalline rock, and tuff. The research should include one of the following strategies. These are taken out of the topic description in the FOA. One is the barrier material development and experimenting, testing, investigating, and characterizing method advancements, or the methods for that. And then data quality improvement and model enhancement, focusing on sensitivity analysis, uncertainty quantification, and reducing uncertainties in the data and the models. The research should address one or more of the following interest areas. One is improve understanding of the waste package failure modes. Now, the narrative in the FOA goes into quite a bit more explanation of what we're looking for here. This is a summary. We're looking for number 2 is improved data and understanding of aqueous speciation and the geochemistry of the radionuclides, their fate and transport in the geosphere. Well, through the engineered barrier into the geosphere. Improvement, understanding, and new concepts for engineering and natural barrier systems, and new concepts or approaches for alleviating post-closure criticality concerns. This is an area of investigation in the disposal of the spent nuclear fuel, and specifically in the FC 4.2 storage and transportation area. We want to develop novel technologies for monitoring spent nuclear fuel and dry storage canisters for the following internal conditions. I've listed them Here, there's in the areas of canister leakage, we're looking for monitoring of helium and or helium air mixture. We're looking for monitoring internal pressure and internal temperature. Changes in these could indicate canister leakage. In the area of monitoring the corrosion conditions and or products, we're looking at monitoring or sensing free and or vapor water and hydrogen in the internal atmosphere. In the area of fuel and cladding degradation, we're looking for decay gases such as xenon and krypton gases. And we're also looking for changes in the dose level. The instrumentation or monitoring systems for these, looking for these conditions, the equipment specs. Generally, we want to allow no penetrations through the dry storage canister wall. So either all the sensors and equipment can be external to the canister, or the sensors can be inside and send signals through the canister wall to equipment outside. For internal sensors, they must be radiation hardened. They must be very small and unobtrusive so that they don't interfere with the placement of the fuel bundles into the canisters. They have to be compatible with the internal components in the canisters and be material that doesn't generate gases or conditions that are detrimental to the package. And they'll have to be self-powered or remotely powered. So that's an overview of our program. And if you have any questions, I'm the lead for the FC 4.2 storage and transportation. You can direct those questions to me. Prasad Nair is the lead for the FC 4.1, the disposal. Dave Sassani at the Sandia National Labs is a national test director for the spent fuel and waste disposition campaign. So are there any questions?
Okay, John, yeah, we have a few questions here. The first one, is recycling considered in this work scope?
No. Okay. No, we're looking at this. We're looking at storage and on disposal of the spent fuel directly out of the reactors. Recycling is a different area of investigation, of focus. The radioactive products of the recycling would eventually have to be disposed, but we aren't addressing it in this program. That's a separate program.
Okay. I see that Prasad Nair is here. Would you like me to unmute him?
Oh, that'd be a good idea. Sure. Okay. Hi, Prasad.
Okay. Prasad, you are self-muted now. You need to unmute yourself now. Okay. Can you hear us, Prasad? We still cannot hear you yet. While we get that worked out, I'll go ahead and start to the next question. It says, is the thermomechanical behavior of engineered barriers of interest in FC 4.1?
Yes. I think I defer to either Prasad or Dave. Is Dave Zassini online?
I did not see him earlier.
No, okay.
Check again. No, he's not here.
Okay.
Sorry.
Me too. But so if we get Prasad on, he can answer that question more specifically, but generally the answer is yes. When you look at the let's see if I can go back to the areas of interest in 4.1. When we're looking at second to last bullet on the page there, improved understanding and new concepts for engineered and natural barrier systems, I think it would come under that bullet there. So the answer is yes. And again,
Okay.
I feel more confident if Prasad weighs in on that. But go ahead, what's the next question?
Okay, Prasad, we still cannot hear you. We'll have maybe Drew work with you to try to get your microphone going. It looks like you're unmuted on our side and you're unmuted on your side. I'm going to go to the next question. Oh, are you there? No. Okay, to what extent does this scope include transuranic waste, if at all?
I don't see anywhere that we would consider transuranic wastes in this topic. No.
Okay.
No, we're looking at the high level wastes from well, basically they come from the defense area in the manufacturing of the defense nuclear fuel, and the byproducts of that production is basically the decay products from the uranium and plutonium from the manufacture of the plutonium. So I don't see transuranic wastes as being a part of this. No.
Okay. How do the site characteristics mentioned relate to the Yucca Mountain site? Is there a site which is more preferable than Yucca Mountain?
Well, what we're doing is looking at basically alternatives to Yucca Mountain, and so we're looking the selection of the site is a really a political decision. Our job is to come up with the technical bases for a suite of alternative disposal sites, and so we're looking at generic disposal sites like the ones mentioned there earlier, the clay, the salt, the crystalline. We've spent years studying the Yucca Mountain site, which is the tough. We don't think there's too much more we can study there, but we're looking at the alternative geologies. So thinking back to the question, I think the answer is no, we're not considering doing any more. We think we've thoroughly exhausted the investigation of the Yucca Mountain site characteristics. Okay.
Sure. Would in situ testing of welds housing of metallic parts be of interest? And this will be to monitor the property change of the enclosure vessel.
Can you repeat that? I can.
Yeah.
What's it? Yeah, go ahead.
In situ testing of the welds and housing of metallic parts be of interest? And this would be in relation to monitoring the property change of the enclosure vessel.
I think I'd have to see more detail on that. I think generally speaking, we're not looking for ways to monitor changes in the properties of the enclosure vessel, partly in the disposal location, because we feel that the changes in properties, I think part of the reason is we think the changes in properties are going to take place over very long periods of time, like centuries. And so long after the disposal site is closed. And so we're not, we don't think we'd be in a position to monitor that level of detail in the changes to the container at that time. We're looking outside of this program, we're looking at ways to monitor changes in the containers during the near-term storage and transportation area, but during the disposal, we are not. No.
Okay, next question. For sensors external or internal to the DSC, which one is preferred?
Well, offhand, I would say we prefer the external one because there's less interference with the operating of with the loading and of the fuel into the canister. But if there's a way to monitor for the properties we're looking for that were listed on that slide 10, we'd be interested in the external sensors, yes.
Are new models for the coupling of heat and mass transfer within a repository environment of interest?
I would say yes. I'd have to look at the specific areas listed on slide 9. And again, the actual details for an answer to that would best come from Prasad or Dave. So if we get Prasad audio going, that would be a good question to repeat to him.
Okay, it sure looks like it's going on my end, but we're not hearing him, so
Okay.
Darn it. Okay, next question. Is solid state additive disposition for strengthening the canister locally in the scope?
No. No, we've had scope like that in previous years, but this year we're looking for the internal, we're looking for monitoring the internal conditions of the canister, not looking for monitoring or improving the condition of the canister cell.
Okay.
Okay.
Could you elaborate on the data improvement for models? Are there existing codes to be used to perform sensitivity analysis, or are models supposed to be developed as new ones?
Well, I think number one, that's a little out of my area of expertise, but we definitely have existing data and we definitely have existing models. I think we're primarily looking at enhancing the data and enhancing the models. I don't think anything precludes developing new models. And the new models are better and have, features that are enhanced over the existing models, then I think we'd be open to those. I think that would fit within the scope of what we're looking for, yes.
Is deep borehole concept considered in FC 4.1?
No, that was a concept we looked at a couple of years ago, and I think we've moved on beyond that at this time. The answer is no.
All right. Is cementitious materials considered under FC 4.1 for the overpack instead of metal alloys or metals, or are they more favorable?
Well, I think part of the idea of this exercise is to come up with new ideas, and I think our past research has sort of focused this in on metals for the overpack, but the body of knowledge changes, and if somebody has an idea where a cementitious overpack has advantages over the metallic ones we've been looking at, I think we'd be very open to considering that.
Okay.
Yes.
Okay. Is only spent nuclear fuel considered as a ceramic waste form, or are tailor-made waste forms for specific waste streams or elements also of interest to this call?
Well, I guess the short answer is no. The long answer is the waste forms are pre-existing. The nuclear fuel is fabricated as a ceramic pellet or a bunch of ceramic pellets, and where this specific program is looking at how to store, transport, and dispose of this fuel. And the same, the fuel pellets are all stacked up inside tubes and bundled together, and we're not going to change that. And the high level waste is the process is to fabricate it into glass, and we're not going to. This program doesn't look at changing the feed stream into the program, either the changing the waste form. That's a given from the upstream process. There are other programs within DOE that are looking at different fuel forms, I guess, and high-level waste forms, but not this program. So no.
Hey, John, can you hear me? This is Prasad.
Yeah, hi, Prasad. Hi, yeah, it's good.
Finally, I got on the phone. Okay, anyway, you're doing pretty good with the answers. Any particular one I didn't hear that need any answers that I can do it now?
Is that Julie on the other end there?
It is.
Okay.
As we go through them, I delete them. Do you remember any, John? We'll have them later as well. We have them once we download the reports, but I don't have them on my screen anymore, the ones we've gone through.
Okay, well,
let me know, Julie.
Okay.
Yeah, we'll review them after and possibly reach out to whoever submitted the question. And if we haven't reached out to you within a couple of days, you're welcome to email one of us and ask us again.
Okay. Okay. For a new question, FC 4.2, does this proposal need to address all sensing functions, or can it only be a few of the listed items?
I would say we'd be happy with a few of the listed items. We'd be.
Okay, great.
That's the full suite of things that we would like to monitor. But any one or more of those would be of interest to us, yes.
Next question.
Got to be original a little bit. So people have done work already quite a bit, so you got to be familiar with what's available out there.
Okay. Next question. Where is the repository site? And how do we know the underground environment of the long-term waste repository?
This is Prasad. We don't have a site, and that is by law right now. It is still Yucca Mountain, but the work, since it's been discontinued for a while, what we are doing is generic studies of all kinds of formations, clay, that is argillite, crystalline, or salt, and to some extent we are looking at some unsaturated sites too. So you're asking about a particular formation. We don't have a formation at this time, but we are studying around the world different formations and bringing to bear what are the critical processes that need to be considered in generic terms.
Okay, next question. Regarding FC 4.2, what are the constraints on the duration over which external measurements on the DSC can be performed?
Was it John? The FC 4.2 is looking at the we call it extended storage and transportation of the fuel, and we don't have a specific time frame for that, but we are sort of planning in the couple of centuries time frame. So that would be like a minimum of 100 years, say, for a time frame. Okay.
Okay. Is there a preference for a certain type of repository, such as salt?
We don't. Yeah, excuse me. Go ahead.
No, Prasad, yeah.
We are looking at all kinds of formations, including salt. We have, for the past 10 years, we have studied different formations. Salt is one of those. And in fact, there is actually work going on in research on understanding the brine flow at the website. So you could look for publications that are out there already in this area.
Okay. Will the monitoring parameters be the same or different for sensors external and internal to the DSC?
John? Yeah, I'm trying to think out. I mean, we want to monitor for the same aspects, conditions. So the parameters in that regard would be the same. Some of the technical specs for the equipment would be different as to whether they were physically located inside the canister or outside the canister. And I think down on our equipment specs, we've listed what those parameters would be. Does that answer? Well, that's the answer.
Okay. Can a coupled experimental computational proposal be considered under FC 4.1?
It depends, yes. Short answer is yes. It depends on what are the processes you're modeling. There's a lot of work being done already. So we have multiple processes and integrated to do computations and what's called performance assessment. So there is significant amount of work gone out there. So you can develop new methodologies for representing processes and modeling them. So we'll have to see on a case-by-case basis.
Okay, is retrievability considered a topic under FC 4.1?
The regulations ask you to have a retrievability option for a period of time before the repository is closed. The problem with, if you have a specific repository site and you have designed some of this, then it becomes more important to design some retrievability issues. In general, in disposal, we think that once you dispose of, we are not needing to, it's going a one-way street. So before you close the repository, if there is a need to retrieve, yes, we should plan for that.
Okay, you mentioned a need to monitor corrosion. Is this corrosion of the internals? If so, is this dry, spent fuel, or are you anticipating long-term storage of wet, damp, spent fuel?
It's considering the corrosion internal to the canister, not external, and it's primarily focused on corrosion of the fuel assembly. And we're looking at the intention is to store the fuel dry, and typically a helium blanket on it, inerting blanket. But dry is relative, and typically there's a small amount of moisture left inside the canister even after drying, and so that moisture is a concern to us in the area of corrosion. But generally the fuel is stored dry with a helium blanket. The corrosion would occur under conditions where there was some water moisture left inside. Okay.
All right. What are the dose limits to be rad hard for sensors in FC 4.2?
I don't know offhand. I can find out and get back to you, but I don't know that number.
Okay.
It meets all the regulatory requirements like Part 2 or Part 20. So people can look it up if they need some information. So all these containers do meet the existing requirements.
But the dose in the regulations is external dose, right? And
right. That's right.
What the question is, what's the internal dose if we have instrumentation inside the canister? What's the radiation level internal? And I've seen the numbers, I just don't know what they are offhand, and I should have found out ahead of time.
It's okay. All right. Would a non-dry neutron poison barrier technology, such as a water-based colloid, be under this scope?
Well, I guess that scope would be looking at the FC 4.1, the new concepts and approaches for alleviating post-closure criticality concerns. And we are looking at various fill materials for the canister that would have radiation, moderators in it, and neutron poisons. Water is typically not a friend to radiation and criticality. But that isn't to say that if there was some colloidal dissolved in the water, that it wouldn't be of interest to us. But yeah, go ahead, Prasad.
Yeah, all I was saying was that you got to be sure that you don't want to introduce within the container any situation that might cause criticality. And so liquids generally should be avoided. We're trying other things, metallic stuff like gadolinium and other things in other work that's being done. So you have to worry about the moderator and long time exposure for that. So colloidal may be a temporary fix, but if you can propose something that really makes it happen without being a moderator, that would be fine.
Okay, are models for fission gas movement within the repository of interest?
Repeat that question again.
Are models for fission gas movement within the repository of interest?
Yeah, gaseous releases are also considered in the performance of releases. And so not only fission gas, any other gaseous elements coming out of the container is analyzed within the context of the natural barriers. So yes, we do analyze a bunch of different gaseous releases, and eventually that has to be accounted for in the performance assessment.
Okay. When you mention data quality, is big data or machine learning something you are interested in?
There is attempt in doing that area. In fact, many of the national labs are looking into those data, machine learning stuff. It depends on what is being proposed. And so I would encourage people to look at what's done and where there's a big bang for the buck, as opposed to just taking all data and trying to machine learn it.
Okay. We have a follow-up question on the corrosion question, and it says, what is the concentration of water in the spent fuel, if you know that?
Usually,
yeah, go
don't know.
ahead, if you know.
No, I don't know of anything, but generally in the container, the spent fuel is fairly dry compared to the outside of the container where it's exposed to groundwater. And so it's not the spent fuel that way will see a lot of corrosion. Like John described earlier, the residual water that might be there in a container, and that can be quickly consumed within the claddings and other things fairly soon. So you have to make a case for how much water is there and how much corrosion can be generated as a result.
Yeah, we have those numbers. We've done research on that. I don't have them at the tip of my fingers again, but it's very, very well. Typically, it's very, very small amounts. If there are instances where water can be trapped in inside the fuel tubes, and water of unhydrated water within the uranium oxide that is residual after the drying process. And those are the situations mostly that we're concerned about is when the concentration of the water is greater than what we designed for. But offhand, I don't know those numbers. Once again, the numbers exist. I don't have them at the tip of my fingers.
Okay, next question. What buffer materials are of interest? And what range of water content in the buffer are of interest?
This is assuming buffer outside the container. Usually most of the buffers we have studied is bentonite, and for fully saturated environments. And a significant amount of work is being done and how the bentonite dries up or gets exposed to high temperatures and what happens to its performance. It generally does swell with heating up, and then it performs to retard the radionuclides from moving out. There are studies that are looking at modifying the content of bentonites. Worldwide, bentonite generally is being used as the buffer material, and people have looked at additives to the buffer material. Now, getting a totally new buffer would be interesting, but whether it adds to the knowledge base is a question that you have to ask.
Okay. Are modeling and testing of microstructures achieved during the fabrication and repair of the casks of interest?
The microstructure, go ahead.
Yeah, they're not. They're not part of this topic. Within, we are interested. We have looked at it in the research topics in other years, but this year it's not considered part of the topic. No.
Okay.
Yeah, part of that comes about by we are looking at existing containers, so we are not going to improve the microstructure of any. We are not fabricating new cylinders to. These are existing containers. So, like John said, we are less interested about it this year.
Okay, for FC 4.2, are simulation results sufficient for developing the sensor and monitoring techniques?
At some point in time, we'd want to prove them with prototypes, but I think initially simulations would be acceptable. I think pretty much we want to start with simulations. And if they look extremely promising, we would take it a step further into prototypes. So yes.
Okay, great. Are neutron and gamma tomography techniques considered for spent nuclear fuel monitoring?
Yes.
Okay.
That is one way of doing it. Yep.
Okay. Would it be of interest in this program to have a virtual reality simulator of repository process facilities?
It is not clear from the question whether it is surface facilities looking to how to bring waste into the facility and then deal with it, or it is the underground facilities. So we haven't spent much in the generic studies to look at any of the surface facilities. So if you are looking at surface facilities at this time, we our interest is fairly low on that.
But in the subsurface facilities, if the model relates to the topics of interest here, such as the somehow relates to the fate and transport of the radionuclides, it might be of interest, though, wouldn't it?
Yes, but usually all that happens when the repository is finally closed.
Yes.
So yeah, and the facilities, John, you're talking about would be the drift and any shaft closure shafts that we do look at what kind of permeability and operational and closure issues they bring about. So yes, those are the 2 or 3 things that would be applicable to investigate.
Okay.
Okay. What did you mean by data quality and model enhancement? Do you have numerical models and model results that are available for PIs?
John, this is FC2 or FC1 type thing?
I'm pretty sure it's FC1.
Okay, the data, we got a lot of models that are looking at different aspects. Typically in the performance assessment, we consider how good the data set is in its uncertainties, and these uncertainties are propagated through the whole system of calculations. So there is an element of quality of data in how it is being used in representing safety analysis. So yes, do we want to look at more how the quality of data affects things? Yes, but then it is always combined with the performance assessment software, and that's what we are doing with it.
Okay. Besides light water reactor used fuel, are advanced reactor spent fuel forms considered?
Not at this time. We don't. Our scope is limited to spent fuel and existing defense waste.
Okay. For FC 4.2 for corrosion, are we looking at the fuel behavior in addition to the canister corrosion?
Yes.
Okay. Another 4.2, are spintronics-based nuclear sensors of interest?
Well, I don't know what a spintronics-based instrument is, but if it monitors one or more of the attributes that we're looking at, then the answer is yes.
Okay, great. I think that is all the questions we have today. I want to thank you 2 gentlemen for helping out with this, and I'm going to turn it back to Drew Thomas of the NEUP.
Thanks, Julie.
Thanks.
Hello, Drew.
Are we done?
I think that's we've answered all the questions, so that's what Julie was saying. Yeah.
Maybe Drew's not there with us at the moment. So in that case, I will just say that we're going to take a break now, and we'll be back at 3 p.m. Eastern time for the FC2 Workscopes. Thank you, everyone, for joining us. Bye-bye.
Thank you.
I put up
Bye.
our emails again if anybody wants to contact us. Bye-bye.
Sure.
Great.
Bye.
Thank you.